Okay, so it says to solve the system by any method. So I could either use substitution, elimination, whichever method you'd like to use. I'm going to solve this one by substitution. And I'm doing that because I see one of these are already solved for a letter. So I notice that this is solved for y. So what I'm going to do is put everything here, negative 7x plus 28, and substitute that in for y here. So doing that, I have 8 and everything in parentheses, negative 7x plus 28 minus x plus 4 equaling 0. Distribute the 8, I get negative 56x plus 224 minus x plus 4. Combining my like terms, negative 56x minus x gives me negative 57x. 224 plus 4 is 228. Now I subtract 228 from both sides. I'll get negative 57x equals negative 228. Divide both sides by negative 57. I'll get x equals 4. Okay? Now I'm going to substitute this back inside for x to find y. So I'm going to put in 4 for x. Negative 7 times 4 is negative 28. Plus 28 is 0. So y equals 0. So my coordinate is going to be 4, 0. And that is my answer. Number 15, I'm also solving for a system, but since nothing is solved for y, I'm going to use elimination in this case. I notice that I can make both of these here 15s. This is already positive 15y. To make this a negative 15y, I just multiply by 3. So I'm going to multiply everything on the bottom by 3. So that will give me 21x minus 15y equals negative 32. So now let's take a closer look at that. Alright, so now I'm going to take that and add that to the first equation. So adding these up, negative 2x plus 21x is going to be 19x. 15y minus 15y is 0. Negative 32 plus 51 is going to give me 19. Divide both sides by 19, you'll get x equals 1. Okay, so now what I'm going to do is I need to substitute that in for x to find y. So doing that, negative 2 times 1 plus 15y equals negative 32. Negative 2 times 1 is negative 2. Now I add 2 to both sides. I'll get 15y equals negative 30. Divide both sides by 15. Y is going to equal negative 2. So my solution is going to be 1 and negative 2. Number 16 is asking you to graph the following solutions. So I have two inequalities that need to be solved for y, so let's take care of that first. So the first one, I will subtract 2x from both sides. I will get negative 4y is less than negative 2x plus 12. Divide everything by negative 4. I would then have y is greater than 1/2 x minus 3. So that is my first inequality. The second one, I will subtract x on both sides. I will get 3y is less than or equal to negative x plus 6. Divide everything by 3. I'll get y is less than or equal to negative 1/3 x plus 2. So now let's go about graphing them. So the first line is going to start at negative 3 and go up 1 over 2, and it's going to be a dashed line. The second line is going to be a solid line starting at 2, going down 1 to the right 3, this side, then reversing it going this way. So to find the shaded part, we will put it into the calculator. So the first one, I would do alpha y equals and enter and type in 1 over 2 x minus 3. The second one, I would do alpha y equals and enter negative 1 over 3 x plus 2. Now for the first one, we are going to be doing a greater than, so that's going to be pointing up. For the second one, it's a less than, so it's going to be pointing down. Okay, so now let's graph them. Okay, so my shaded portion is going to be right here. So let's look at that in terms of our graph. So shading it, we saw the shaded portion goes in here, so my solution should look like that. It should be this part here that's all shaded, and that is number 16. Number 17, we are looking for f of x for all these values of x. You can get that by going to the table on your calculator. So to find that, press math, press over, and enter for your absolute value function. So then we do x plus 2, press the arrow to go outside the absolute value and do minus 5. Then we do second graph. Our first x is at negative 6, so negative 6 down to 2. All of this here will be my solution, so let's put those into our table. So filling in the table, we end up with this. Now looking at a graph, it's absolute value, so you know it should look like an absolute value graph. So when I plot these points, it looks like that, which is exactly what the absolute value should look like. This one is shifted down and to the left though. Now I connect them, and that will be my graph for number 17. Number 18 is asking you to graph the following. So we need to solve for y first. We divide both sides by 2. We'll get y is less than 5. Now this is a horizontal line going through 5. So we graph that. It is a dashed line because it's an inequality. It's a less than, so that means I shade below the line. So this is what your graph should look like. And that is number 18. Number 19, it is asking me to graph this inequality. I have 5x is greater than or equal to negative 10. To solve for x, I divide both sides by 5, and I get x is greater than or equal to 2. So now this is going to be a vertical line going through negative 2. X equaling a number is a vertical line. There is a line under it, so it will be a solid line. When you are shading the inequality of that, you shade the way it's pointing, which will be on the greater than side. So you shade that, and this will be my graph for number 19. 20, it is asking me to graph the following system and indicate how many solutions it has. So I need to solve both of these for y first. Starting with the first one, I subtract 5x from both sides, and I get y equals negative 5x plus 3. Let's look at the second equation. For the second equation, I divide everything by 3. I'll have y is equal to 6 minus 5x. Now I graph these. The first one, I start at 3, and I go down 5 to the right 1, so it looks like this. The second one, I start at 6, go down 5 to the right 1, and I notice that they are parallel lines, and that means it will have no solutions. And that is my answer for number 20. Number 21. It is asking you to write a system of linear equations to solve the following application. So the bicycle store costs $3,200 per month to operate. The store pays an average of $60 per bike. The average selling price of each bike is $100. How many bikes must the store sell each month to break even? So we got to set up x and y first. Let's let x be the number of bikes sold. Y is going to equal the expenses and the income. The first equation is going to be expenses. My expenses are the $3,200 per month and the $60 per bike that the store pays. So putting that together, I'm going to have y equals the $3,200 plus $60 per bike, which is x. So y equals 3,200 plus 60x. My second equation is going to be my income. That'll be y equals 100x because each bike is $100. Now it's asking you how many bikes must the store sell to break even. When you see the words like break even, you got to set them equal to each other. So doing that, set them equal to each other. Subtract 60x from both sides to solve it. 40x equals 3,200. Divide both sides by 40. X will equal 80. And that means the number of bikes sold is going to be 80. And that's number 21. 22, it says a population of marine bacteria doubles every hour under controlled laboratory conditions. The number of bacteria is modeled by the expression 1,200 times 2 to the h power, where h is the number of hours after a scientist measures the population size. Evaluate the expression for h equals 3 and h equals -4, and then what does each value of the expression represent in this situation? So I simply put in h3 for h in the calculator. And doing that, let's look at it. So I have 1,200 times 2 to the third power. That gives me 9,600. So let's put that in for the answer. So the evaluated expression is 9,600. That means there are 9,600 bacteria. Now, seeing how this is a positive number, starting point is 0. Since this is a positive number, it would be after 3 hours after the scientist measured. So 3 hours and after the scientist measured. For the second one, if I put in -4 in for h, it'll be 2 to the -4 power, I get 75. So that means there are 75 bacteria. And again, remember 0 is a starting point. So -4 means it'll be 4 hours before the scientist measured. And then that is number 22. 23. The diameter of the moon is approximately 3.5 times 10 to the third power kilometers. The diameter of the earth is approximately 3.7 times the diameter of the moon. Determine the diameter of the earth. So if the diameter of the moon is this much and the earth is 3.7 times that, we're going to multiply them together. Okay, we can simply do that on the calculator. So we have, in parentheses, I'll put it, 3.5 times 10 to the third power, go outside to close the parentheses, and that's going to be times 3.7. And it gives me this. But it wants our answer in scientific notation, so let's go back and put it there. So we have this, and we have to write that in scientific notation. So to do that, I have a decimal point in front of here that I got to move 4 places to put it in front of the 1, because remember this number here has to be less than 1. So doing that, I move it over 4 times, and I'll have 1.2950 times. Now when I move to the left, I add to the exponent, so I have 10 to the 4. I went to the left 4, so it's a positive 4. So this will be my answer for number 23, and that is your study guide.